All right, let's start talking about roots. I want you to imagine yourself as a primitive ancestral land plant. You live off the sun and water on your primitive leaf-like structure. You found a nice spot in the sun. But paradoxically, the sun dries you out of water. Evaporation happens, and that water that you need to complete photosynthesis, it's not available all the time if the sun is beating on you all over your body all the time. So you need a way to get water while keeping your green parts in contact with the sun rays. Also, there's wind, and you want to keep your nice sunny spot. You want to keep yourself grounded in this nice sunny home. So you've kind of got these needs, these environmental pressures. And what happens is by adapting to have separate compartmentalized parts of your body. Early plants had leaves that sort of didn't need to worry about desiccation as much because they had this other part of their body that was sort of focused on getting roots, that was specialized for getting water, for getting water. There's roots who don't need to worry about photosynthesis because their above ground part of their body is doing that. So there's no need to waste your chloroplasties on those roots. Luckily, the sun doesn't shine underground, and so roots are able to shade themselves out. This reduces the chance of desiccation in roots and the rest of the plant. So, if you're this primitive plant, you probably won't move for your whole life. You need a way to stay in place as well. So you need to ground yourself wherever that may be, which a lot of times is on the ground. That's where you think of roots, right, is underground. But not all roots are underground. Some are above ground. Maybe they're attached to a tree or attached to some other structure. But the main point of what I'm saying here is that roots will provide structure. They do absorb water and they do absorb nutrients, but they also do support and ground the body of the plant, wherever that may be. Actually, when we look at an entire plant body, we realize that a pretty good proportion of the biomass of this body is occurring in the roots. They grow and branch underground, sort of like feelers feeling their way for water. And by doing so, they end up getting more stability and making it kind of harder for the rest of the above ground body of the plant to get knocked over by, say, wind or something. Also, of course, as they're doing the stabilization for the plant, they are, of course, collecting water and nutrients for the rest of the plant and sort of moving it upwards. Sometimes roots are fibrous, like you can see in these pictures. When that is the case, a lot of very small, densely packed roots tend to kind of grip onto whatever their surroundings are, including dirt, soil, all of that. And so it's really, they are really good at solidifying the ground and preventing erosion, essentially. They are, when they're fibrous like this, you see lots and lots and lots of roots, lots of branching. Another way that you might see roots is something more like this. This we call a taproot. A lot of times deep taproots are searching for groundwater that's nowhere near the surface. And so oftentimes plants will shoot out this one long taproot. When that's the case, they will oftentimes also shoot out these smaller secondary, sort of lateral to the side roots as well. And maybe that would be beneficial for them in case there is a rain. It might also be nice to have those shallow roots up top for rainfall, and then have that deep taproot looking for groundwater all the time. You also know a couple of classic culinary taproots: carrots, radishes, beets. All right, that's all.